So cool, science! Is it true at noon the equator casts no shadows? Wow, that's a wicked cool question. I got a wicked cool answer that's gonna have you saying, whoa, that's so cool. You know, well, unless you're a fart knocker. I mean, a flat earther. Hi, I'm gonna show you a wicked cool demonstration that's over 2,000 years old, but it still packs a punch. You know, kind of like a Russian grandmother. And of course, all you're gonna need is an everyday common index card, and you can prove the Earth is round. You know, the stupid people. People so stupid they go fishing in the frozen food section. Get yourself an index card and tape 2 bent paper clips, 1 to each side. And of course, now you're ready to prove that the Earth is round. Check this out. Okay, so when I move the light over the card, when it's flat on the table, the shadows stay exactly the same. Okay, so that's not how shadows work here on Earth, okay? So check this out. We're gonna bend the card and place the light directly over one of the paper clips. Whoa, now check that out. You had a shadow on one side and no shadow on the other. That's pretty wicked cool. That right there proves that the Earth is round right there. See, 2,000 years ago, they did this exact same thing and they believed that the Earth was round. And then 2,000 years later, you got people here, they got satellites and all sorts of technology and people are like, oh my God, I can't believe it. So, how does the bent index card prove the Earth is round? And what does this have to do with, well, the equinoxes? Well, don't look at me. Take a closer look at this. Since the Earth is tilted and goes around the sun, different amounts of light will reach the Earth at different times a year. Around mid-March and September, the Earth's axis is neither tilted towards or away from the sun. This puts the Earth's equator at a 90-degree angle to the sunlight. So we call these the equinoxes, or equal night. This is also why there are no shadows during noon at the equator during the equinoxes. Eratosthenes, an ancient Greek philosopher, noticed that where he lived, Styx cast shadows, while 800 kilometers away, near the equator, there were no shadows at the same time. He realized that the Earth has to be curved. The shadow he measured was a 50th of a circle, so he multiplied 50 by 800 kilometers and got 40,000 kilometers, or the circumference of the Earth. Ships sailing over the horizon didn't fall off the edge. They gradually disappear and then they came back. The Earth sometimes casts a shadow on the moon. That shadow is always round, no matter what. So now you know more about No Shadow Day. You know, being able to prove the Earth is round right at home with an index card is why science doesn't throw you a curveball.